Hello, everyone. Thanks for joining my talk. I'm aware that it's me and then drinks, so I'll try to be a little quick. We'll probably only take half an hour. You're welcome. All right, so today we're going to be talking about Harry Potter and the Elastic Python clients. That's a mouthful, just like all Harry Potter titles. But we're going to go through why I chose the title, and hopefully at the end of today, maybe you know a bit more about Harry Potter, but you'll definitely know a bit more about what to do with Elastic, and particularly with the Python clients. So I've joined Elastic in August as a developer advocate, and since then I've been catching up with how the search engine works. For those who don't know, Elastic is the company behind Elasticsearch, what they're best known for, but they also do a lot of analytics and security, observability, basically any kind of data collection and ingestion, and then searching through those logs or metrics in a very fast way. But all of that sounds very important and businessy. I just wanted to see what can I do with that, and books. So to answer maybe the first question of why Harry Potter, other than the fact that I just am a really big fan, I think that it's a really good example of, first of all, a domain that's really well known by a lot of people. So then when you build different programs on top of it, especially with semantic techniques, which we'll get into, then people kind of know how it works, so they can tell if it's correct or not. This is one example that I used to give when I would give talks about just data science and ML in general, which is how machine translation is done. So I've read the books multiple times in English and in Romanian. And even if you don't know Romanian, if you look over the page, like the first page of Harry Potter, and you know it in English, you can probably tell what's going to be on that page, even if you don't speak that language. And that's exactly how machine learning does it as well. They don't actually learn a new language, but they know if two things are supposed to mean the same thing. They learn those connections, and then when you ask a question in English and you want to translate it, it'll see, okay, what would be the equivalent? So I've been giving a lot of talks about how Harry Potter proves ML principles for a while. But I think specifically this one, I have been most inspired by this article that came out in, I think, 2017. So back in the beginning of when Word2Vec was really popular and Gen AI was just starting to get around. And luckily, that's also when I was really into data science in my bachelor. And what came out is that they wrote a new Harry Potter book with Gen AI in the style of J.K. Rowling. And I mean, if I say it now with everyone having worked with ChatGPT, it doesn't sound really cool, I guess. But back then, it was like mind-blowing that you could do something like that. And it was like one of the first examples where people thought, oh my God, this is like so cool, and it's going to be really nice in the future. And yeah, we are where we are today. But basically, this is like one step forward. If having the books in different language one by another would be translation, then this is generative AI, where you create completely new sentences or completely new context from data. And data, in this case, while most of the time data is like a table and columns and numbers or whatever, in this case, the data is the book. So the sentences, the words, that's kind of how semantic search or any sort of NLP processes work. So also why I like building solutions on top of Harry Potter, because there are a lot of books. For the second part, and the Elastic Python client, that comes out of a small frustration of mine that I program in Python mostly. I don't think Elasticsearch was as commonly used with Python. Most people would work with Java or Go or another language. Or at least it used to be like that. Now that we have a lot of Gen AI and semantic search capabilities, Python is getting more and more popular. But when I joined and I looked into, okay, what can I do with Python? I was a little overwhelmed because there's a lot of Python clients and they all do something slightly different. So we're going to try to understand how that works and what is like the coolest thing you can do with it. So if you're familiar with Elastic, this is like the newest stuff that you can do with it. If you're not familiar with Elastic, well, you're going to think it's a lot cooler if you start with this. So the number one client is the Elasticsearch Python client. How this works is you can just install it normally, and it's a very high-level client that is built on top of the APIs of Elastic. So if you're not familiar with it, the way that you can search for things in Elastic, you send in a query in the form of a JSON through an API call, and then you get back the result, right? So you have to build those JSONs and a lot of squirrely brackets everywhere. And this helps you do that a little smoother, but not by much. If you want to make more Pythonic language, so to say, then we also have the Python DSL client, which is built on top of the previous one, but has things like classes and functions, and it's just a little bit more robust. So to give an example of what this actually looks like, with the Python client, you can see that you have the query in there that basically looks exactly like you would send it with another language, or in the dev console if you want to try it out, or with whatever API tool you have. So this kind of helps you be more flexible with it, because you could have one query and then you can choose to use different languages to work with it. Whereas the DSL client looks a bit more like a Python script, which is good if you want to not have huge JSONs in your files, but it's also very Python specific, so you're not as flexible. This is the difference that I've noticed so far, but it took a while to figure out what to use, when and why. My conclusion is I like coding in notebooks, and if you're like really quick with scripting and you want to try stuff out, the main client is perfect. If you want to build classes and you think you're putting together a lot of the operations in the main client, you're just rebuilding the DSL client. So also check that out. It has a lot of utility functions in there. So you may think, okay, this is not that bad. You made a whole deal about how you're making a talk out of it, but there's 2 clients. Bam, there's 3 clients. And this one is actually called Eland, because we have a thing with, elks, like elk stack. If you've heard about that, that's our mascot. You can win one at our booth, I think. But basically, this is a data science specific client, which, I think most Python clients are kind of ready for data science. But this in particular has its own data frame, which is kind of trying to reproduce pandas. I wouldn't say that that's the top use case for it, but what we do use Eland for is that it allows you to pull in external models from other libraries into Elastic, which is where the cool stuff really happens. So what we can do is from compatible libraries, such as Hugging Face or from OpenAI, we also integrate with LangChain. So yeah, if you've worked with data science or semantic stuff, you'll be familiar with those. What we can do with Eland is say, hey, that model that's been created over there, bring it into Elastic so I can start making calls to it. So we don't train a model, because that's the computationally expensive, difficult part, but models that have been created and trained on really large data, we can just bring them in and use them for inference. So in the same cluster that you would do your traditional search, so to say, you can now add this whole extra layer of an LLM that can do a lot of cool stuff, which we will explore. So before we go to the demo, summarizing, we have the books, unstructured data, works really well for documents. We have the multiple Python clients and a bit of chaos there, which made me want to make a tutorial out of it. And we have LLMs, because everyone does that now. But to be fair, we've been a vector database for quite a while, and it's just becoming cool, but we've been doing it for a while. So let's see what that looks like. Still works, okay. So this is the Elastic homepage. Again, I'm assuming maybe you've seen it before, but if not, you can do search, you can do observability, security, analytics, all that stuff, and we'll go through a bit of the main features today. So if I have data in Elastic, I can first look at it by making a dashboard, for example. So I've made this really quick visualization. This works like any other BI tool, really. You just drag and drop some visuals, and then you can interact with it. So say, you're looking at the Harry Potter houses and you want to find a specific character. I want to look at all the Slytherins. I want to look at the pureblood Slytherins, which is probably all of them. And then you have 11 people, whatever. So this is kind of a search process as well, but just done visually. So it's a lot easier and not super techy, but gets you there pretty fast. However, even though you see the selections here, if you're looking for more advanced queries or you want to save the queries, this can only get you so far. So one thing you could do next is you can go to Discover. And in here, you can select from all the indexes you have in Elastic. So in this case, index is the thing that we store our data in. And then you have all the hits in there. So for example, this index is made up of the Harry Potter characters, where each field is pretty much a property of those characters. So we have the date of birth, we have blood status, house, stuff you've seen before. And then you can search for it in here. So for example, if we do eye color, and I say blue, Nothing happens. And that's because I said blue with a small b. So you'll see that this search is quite sensitive to exactly the way that the results have been stored in there, because I've categorized them as keywords. So while we can use this again to search, and it is easier than the dashboard, because I can also use aggregations, like I can say house Gryffindor and whatever, then we only have 6 hits. It's still classic search in the sense that you need to know exactly what you're looking for, and if you know what you're looking for, it's great, but most people who use search don't always know what they're looking for, so we might want to push that a little further. How we do that then? Go to the next level. We can use our DevTools console. So again, like I mentioned before, Elastic works with these queries in JSON format. The tools we've seen before kind of abstract that away for you, but you can use this kind of to test out the things that you want to run. You would do this, or you would use a tool like Postman, or as we'll see later, you'll use the clients. Basically, if we run one of these searches, I can make it a bit bigger. So this says, the house has to be Gryffindor, and you get this really long results with a lot of metadata, basically saying you have 38 hits, and you get back each entry in that database, which is saying, okay, this one is name Ron, and the second person is Hermione, and so on and so forth. It collects all of those for you. And you can make this more complex. So for example, in here we have a query that searches for multiple words within a field. So there are ways to make that more flexible depending on how you define the fields. And this one gave me 9 people who are loyal to either of these organizations. And you can make like really complex queries that say, okay, I want their job to say one of these things, either as their job or their skill. I want the house to be this exact value, spelled exactly like this. I want them to be born after this year, and I want them to be redheads. So if I run this, did I run this? Nope, apparently I wrote it wrong. One of these, well, that should have given me all the Weasley population, because redheads in Gryffindor. But basically, yeah, you can add as many of these operators as you want to make complex queries. But this talk will be about the Python client. So how does that look like in Python code? Is this big enough for everyone in the back? Cool. What we can do is we can connect to Elastic from our code. You just use an API key for your authentication and get connected to that instance. And then this query that we would have run before, we can now run in here. And we get the same really long JSON that we would have gotten in the dev console, but because we're in Python, we can actually like format it a little bit easier. So if we rerun that, wait, I want to do it live, we get 31 results, but I'm only printing their name, so I don't have to scroll through that whole thing. So that's kind of the use of using a client. You can make it a bit more complex, and you can really process your results as well. So this also works with these really long queries. Pretty much, we just make a search request to our index with the exact query we saw before. And this time it actually runs, and we have 3 people. This is great, but again, even though we can have more flexible queries in the text fields, we want to take it a step further. And for that, we are going to use the newest capabilities of using semantic search. Well, this was just an example. Pretty much, the thing I mentioned before, Elant, can be used to bring in Hugging Face models. And Hugging Face is this library of data science models that have been trained, and we can do all sorts of tasks. We can do classification, we can do Q&A, we can do generative AI, we can do keyword extraction and all this stuff, and we can also combine them, and we can do hybrid search. I get this question a lot from people who work with Python and would use like an embedding model to do search, and then they think, okay, then why do I need Elastic? We're coming from a search perspective and adding embeddings to it, so you still get all the capabilities of running really optimized and fast queries, doing filters, doing different kinds of aggregations that have really optimized data usage and speed, and you can use embeddings. So that's going to be like really powerful to create hybrid search scenarios. To start with, I'm going to show you how we do sentiment analysis. So I'm starting up a new cluster. We're connected with Elastic. The documents are in there and they work. We have to run this Docker container to connect to the model that we want to take from Hugging Face and bring it into Elastic. And we only have to do that once. Once you're done, you can do this simple post request to get back the results to the inference cluster. So if I do this in the Python client directly, so we don't go back and forth, I can basically run inference results, not on this one, on any session that I want. So I said, this session really sucks, negative. If I say, this session is going well, hopefully, now it's positive. And you can do this for pretty much any sentence. You can just make an inference call, get back the result. But then again, because we have Elastic and all the functionalities, we will then create a pipeline that allows us to take our index and then send every single document through this process of getting that inference results back. So then we're basically enriching our index with a new dimension, which has the sentiment property. So we're just saying, okay, I want to take my Harry Potter, I think I did the books and I did the movie scripts, and I want to know all the sentences, are they positive or are they negative? And then if I run this, here I'm looking for the results that have positive or negative sentiment. And for each, this is like the script of the first book, if you can read it, like the first movie, how it starts out, and it tells me for every sentence if it was positive or negative. But then because we have a search engine, we can just use that sentiment as a filter. So I can look for the most negative quotes in the books. And I've added these in here so you can read them a little easier. But in case you were curious, this is like the most negative that Harry Potter gets. It's not super dramatic, but you can really see that this wouldn't come up in a sad search or whatever you would use with keywords, but the sentiment can really bring it out in a different dimension. And to be even, we also have the most positive quotes. I think a lot of these are from book 2, but regardless, I think the results were quite funny. And again, because people might know Harry Potter, it's a little easier to interpret that it makes sense. So this is something that we can do with our sentiment analysis. This was the script that generated the positive events. And you see we also have a score of how positive that is, so you could definitely use that for filtering. And then what we want to do to make it even more complex is bring in semantic search. Semantic search, maybe you've already seen a talk on it. I'm sure there's plenty at most of these conferences these days, but we're creating embeddings so that we can use this multi-dimensional space to find sentences or words that are semantically close to each other, like synonyms or things that belong to the same category. And if we embed them that way, then instead of searching by word, we can have a query that we vectorize, and then we find all the similar results within our database or index that are close in that vector space. So it's a new way of doing search, and we can do it with Harry Potter as well, of course. So again, we are connected to the environment. I'm doing a Docker run to bring the new embedding model, also from Hugging Face, into Elastic. And then I can do stuff like this. Let me run it in the console this time. So then I can show you. So this was the sentiment one. You run it, you get positive. This is the embedding. This looks a little, not as easy to interpret, but basically you get this result of a very long vector with a lot of dimension that represents this sentence. So then I can look for similar sentences from it. So if I do that, this was the conversion, and then I create another pipeline, so I can, once again, every single sentence, besides knowing if it's positive or negative, I also know where it fits in the embedding space, which then allows me, well, that doesn't look good. I hope that runs. If I do this, we get the embeddings, and then we can search what are similar words to things. Does anyone want to shout out something you want me to search for to make it more interactive? No, you don't? Okay. So we're just going to switch this to I love books. Hopefully we get something with Hermione in there. So we're just running this. I made it into a list so we can see multiple results at once. Can we see multiple results at once? That would be great. Oh, I didn't run the client part. This one. this one, and then this one. Yeah, always happens when you're doing code live, but at least you know it's real. So if we run this again, then we run this, magic. I love books. We see that love has picked up something. Books and cleverness, that's a Hermione line. Selling books, I don't like this, which is similar to the love factor. So there's different things that get picked up in there, depending on how the model was tuned as well. And you see a few more examples as much as you can. For example, if I look for Harry Potter, because it's categorizing it by score, it will sometimes get that exact match as well, which then, of course, it's semantically very close, but maybe it's not as interesting for us. And that's where our hybrid search element comes in. I can start tinkering with that and define what I want and what I don't want to come up in that search. So for example, and then again, I have these in slides because they're quite hard to read in the document. But what I can do is I can start with a simple search, say Brave. If I look for Brave with the semantic search, which, by the way, the query looks like that, so it's still really simple to run, we get these results. So we have a lot of Brave, we have Courage and Bravery, which are similar to it, but a little bit different, so they wouldn't have been picked up by the normal search. But then I remember that I actually have a second LLM in there, so I can add that dimension. I can say, I want to do semantic search on Brave, but I also want it to be negative. Then it's going to pretty much give me the opposite of Brave, which is risk and fear and coward and fear and fear. Okay, it's a lot of fear. Again, maybe I don't want to have the same result 5 times, but because we're using Elasticsearch, I can also use the simple filter capabilities. So I'm just going to say, don't bring back the word fear. You still see fears in there, which is slightly different, but that's again because the filter works on exactly the word that you put in. But now we have more diversity of results. So I have risk and coward and mean. So you can see how going with all these different layers makes a more complex and interesting search experience. And here we used 2 different LLM models and some of the filtering capabilities. You could also sort this by where in the book this appears, like maybe you want it earlier on, maybe you want it later on, maybe you want this in a specific character to say it. The possibilities are endless. And again, this is a cool example that's like fun with the Harry Potter books, but you can imagine how this works for searching through actual work-related things. We've had someone do this with user reviews to come in. Maybe you want to review the most negative, angry ones, or you want to send them by topic to different departments to deal with. There's a lot of different applications for these that aren't just fun and magic, but this is more fun and magical. So to summarize, again, we've used semantic search, and to do that, we've done embeddings, which really help us search in that semantic area. That's a part of machine learning, part of natural language processing, all these buzzwords that you hear around. And it's all powered by the fact that we have a vector database. So we're able to store those really, really long lists of values that you've seen earlier, and we're able to calculate distances between them, and we're able to, make that count for our search results. All of those things together can make a really compelling story, and I hope you enjoyed it, and especially the Harry Potter part. This is the picture slides if you want to remember what clients I talked about, and that is all for me. Thank you.